Oh, so people can just watch those recordings whenever it be convenient. Now, with respect to a recording of lectures, I can do this for all lectures, but there is a little limitation. The college has only 30 days for recordings and then they expire. So if you wait for a couple of months and try to watch the recordings of first days of class, well, you won't be able to because they will be gone, because 30 days and that's it. Then our college erases those recordings for some reason. So, well, I guess one needs to be aware if you missed the class or missed a week of class, well, that's okay. You could just watch the recordings that I will email to you. I already been emailing you some links to those, so I'm sure you can find this if you check your emails. So anyways, let us start. And we had a little quiz last time, so we are in our textbook, and this textbook I found for free online. I can just go back here and show you what I typed. So I just typed calculus and its applications, and I found the PDF files. You always need to add PDF. So I found a free, absolutely free textbook, and that was, I believe, here, very first choice. Let me click on it. And the Bettinger and Company's textbook is right there for us for free. I hope you all already downloaded this to your device. So it's important that you are able to have access to the textbook. So we're going to, well, look at the contents of this text and, well, get to the sections. I guess that's the convenience. So I'm gonna click on R1, that's our first section of first chapter, and take a look at what we did last time. And we also had a little quiz last time. So today's goal is just to continue with this section because it has quite a few interesting exercises. So we noticed that these problems were dealing with various different graphs. So we graphed some lines. We also graphed some parabolas, like we had in problem number 13, 14, and also in exercises 19 and 20 that were dealing with graphing of parabolas. In fact, I think I asked you for a quiz to do problem number 14 last time. So let me do it for you right now. So the exercise 14 is talking about graph of parabola y is equal to x squared. So that's one of the standard graphs. Sometimes people call it a graph from library of functions. That's a parabola x squared. That's a U-shaped curve that we need to bring 3 units down because we subtract 3. So it turns out the graph of exercise 14 problem is same parabola, but it went down by 3 units, and that was the question for the quiz. Did it go up or down? So if you said down, then you did it perfectly fine. If you said up, well, then you can fix this. So you bring this 3 units down, the whole picture. So you can fix this by doing any even exercise and emailing me picture of your work. For example, you can do problem number 12 or problem number 10 or problem number 8. I say, what about problem 2? You can do any of them. Any, just whatever even problem you like to do. If you want to get extra points, you can do it and send it to me by email. So make sure that you tell me that you are in 10 o'clock class. So this way, for sure, I'm not gonna confuse you with someone else, because I got like 7 classes and sometimes it's hard for me to figure out what class the student takes. And that's why I guess it's important that you're clearly let me know, so this way your points will be yours, not by accident go to somebody else, right? So whenever you want to do some extra work to get extra points, well, you can send it to me. Even if you did quiz perfectly fine, if you want to do some extra to get extra credit, well, don't hesitate. I accept extra work. I give you extra points. In fact, if you send me lots of extra credit, I'm sure you will get an A on that class, because I just add this all to your total, to your final, to everything. So that's why always support students study. Just again, whatever you do, make pictures, send it to me by email, or just tell me that this is extra credit for business calculus or for 10 o'clock class. So that way I will know for sure and right away give you those points. Okay. So we're back to the section, and looks like we worked with graphing of parabolas. So they were going up or down. And now I'm gonna look at another very popular graph that appears in math classes. That's an absolute value function. It turns out the absolute value function looks like a check mark. So in exercise number 17, they want you to graph y is equal to absolute value of x. So this graph looks like let me get another color, a little check mark that goes here and then there. It turns out when you take absolute values, it's always positive. It's never negative. So y coordinates can only be positive. So this graph is simply above x-axis. So the y coordinates are always going to be positive. Other function that, and that's the last function that the section shows us, is a cubic parabola. It's y is equal to x cubed. So that parabola looks very similar to the favorite x squared, but now it's one that goes down when you look at the negative part of x coordinates, because negative number cubed is negative. So you can see the resemblance of x squared and x cubed. They behave similarly to the right from y-axis, but then it goes down. So that's another function that is good to be familiar with. In fact, if you took college algebra class, which is MAC 1105, you probably saw these graphs quite often. These are very, very popular functions. And well, we just do the refresher in this little review chapter. So it's a good idea to see them once again. So it looks like if I have a cubic parabola, y is equal to x cubed, and if I attach a minus sign to it, what I need is to reflect it through x-axis so that the upper part turns into the lower part, and the lower part of cubic parabola goes upwards. So analogously to parabola x squared, where we, if you remember last time, looked at negative with x squared, well, then it goes down sometimes, and that's the way it is. And if you put a minus sign in front. So I'd like to do the problem with x cubed, like exercise number 21. So let me try it, 21 for you. So this is y is equal to x cubed minus 1. Please notice that purposely I isolated y. So I didn't want to have y plus 1 here. 1 I can bring to the other side of equation, so I can isolate y, so I see what y is. So then I can utilize this new graph of cubic parabola, and since we subtract 1, bring it down 1 unit, so the function is going to look like that somehow. So x cubed minus 1 is right here. So that's the result. So if you just logged into class, if you're in the classroom, please let me know, because I want to see what's going on, and who is in the classroom. If people in the classroom were able to log into Zoom or not, because I guess it's important that we all be on the same page. Or if you're on your own, in your place, not in the classroom, you don't have to let me know. But if someone is in the classroom, please notify me. I want to see what's going on, because it looks like not everyone from class is here. I have just 9 people, because there's 10, but I'm one of them. So 9 people were able to log into Zoom, and we actually have like 20. Oh, most of you in the classroom. Very good, very good. So if someone in the classroom was not able to log into Zoom, please don't worry, that's okay. Just get help from library, because if you just go there, they're very good, they're very helpful, they're very nice people there. And also tell them that Alex recommended to get that free notebook, and I just want to make sure that you don't panic and not worry if technology is not working, because that's totally not your fault. I'm not gonna give a quiz today because of that. So it's just fine. I hope by Wednesday everyone will feel a little bit more comfortable. Plus, I think there's someone added this class a little later, so I want to make sure that everyone has syllabus and is able to be with us. So anyways, problem number 22 is another exercise here. So let me try that one. And for problem 22, analogously, I'm going to isolate letter y. So I'm going to bring that 7 over to the other side. So I'm going to do problem 22 by writing it as a y is equal to x cubed plus 7. So this way we have a good start. And now you can see that the graph here should probably be shifted up by 7 units, right? The graph of parabola above the cubic parabola needs to go upwards because we added, so it moved up by 7. So usually people just put 7 on the y-axis, and this way we can see that the graph is actually clearly moved upwards by 7. So that's the rest of section. So I guess I finished with it. So all you can do is try a few problems for practice. And yeah, if you was able to log in, that's great. So if you're in the Zoom, that's super. Even if it's a little late, it's okay. Main thing that you are with us. So anyways, let us try to see what else is here. So I'm gonna scroll down a little bit. You can see there's a bunch of so-called application problems that I'm not gonna worry about for now, because that's just a review. We will do applications that belong to calculus. And here is just some stuff that from previous classes. And my main concern is to make sure that you're ready for calculus, not just playing with some applications. So section 2 of chapter review is called functions. That's a very familiar word for everyone, I hope. So the main question, what is this? What is the function? Because we say function here, function is there, but what is it? What is the function? Well, the key idea is that function is a relation. Like on the picture, they show you, that's a beautiful picture, I just utilize it. So domain and the range. So we start to relate elements from domain to elements from the range by using some kind of relation. And that's actually how we create function. We relate one set to the other. We relate the domain to the range. So we start at domain of the function and we end at the range. So that's how we produce those functions. They are relations in between sets. So they have various relations here, and one of the relations on the bottom is not a function. So this relation is not a function. And the other relations are functions. So what is wrong with this particular relation? Why this relation is not a function? And the answer is Chicago is related to more than one element. And that's what makes this be not a function. I say, Alex, can't two teams belong to the same city? What is wrong with that? No, nothing. But from point of view of function, you relate one element only to one, not to two or three. And that's what makes this not to be a function. But it is a relation. It's perfectly nice relation in between two sets. They have domain, they have range, but it is not a function. And here we have a function. So we related each year to just one element in range. Or in D, we also have a function. I say, Alex, but you're related to teams to one city. Yes, but the rule is not to relate one element to two, but two elements could be related to one for the function. You see, that's kind of unclear what is going on. Well, it's just a definition. So one just needs to get used to the word function, and we're not going to get very deeply into this, but I just wanted to show you the functions and what they are and what will be not a function. So, for example, here on the next page, they have a graph of a relationship that is not a function. So what is going on here? Well, what they do is they show that one element on this graph, such as element X, is being related to two elements, to this one as well as to that one. We use graph to see what is related to what. So we can see that so-called X1 is related with Y1, right? Because that's the pair X1, Y1. And also that same exact X1 is related to Y2. x1 at the same time is also related to y2. And that's what makes it be another function. And they shown it on a picture with so-called vertical line test. Did you ever hear that statement? Vertical line test. What does that mean? Well, it means that we just found a vertical line, that intersects our graph at more than one point. So if you intersect it at 2 points, that's it. It's not a function. Or more than 2 points. Like here, for example, we have a function of so-called parabola because there is no way you can find the vertical line that will intersect it at 2 points. Any vertical line you can think of intersects only at once. I say, Alex, your lines are not really vertical. Yeah, I should be more careful, of course, practice with verticals, but that's the idea. So if you have a graph, and if you find the point, the actual vertical line that intersects at more than one point, that's it. You don't have a function. For example, part B up here, it is not a function because you can see the vertical line that intersected twice. There are actually lots of other verticals, right, that intersect more than once. Same with problem C. It's not a function either because we can find vertical line that intersect our graph more than once. So these are so-called not functions. I say, looks like the others are also functions. Well, here's one more, not a function. The reason is that this vertical line here intersects my graph and at this point and at that point. So it's another not function. Well, the rest, the other three are functions. I guess that's what they're telling here in the solution. So this so-called vertical line test is here for us, and it tells us if your picture gives you a function or not really. So function or not function. Well, I guess we'll be using the word function, and in this class we'll work with functions. So pretty much everything from now on will be a function. So one needs not to worry about not functions because usually we don't consider them in our classes. But it's good to know that something is sometimes not a function. So, well, I guess not a big deal, just not a function. Just okay, let it be not a function. What happens here in the next example? I just want to look at the pictures they provided us with because I think they made very, very nice looking pictures. And the next example is dealing with something a bit unusual. So next example, they're talking about so-called piecewisely defined function. So here's the function, and people usually call it as f of x. So instead of y, we're going to be using letter x as a function of x, f of x. That's what it is. So it's not multiplying, it's just the definition. So it's a function of variable letter x. So what happens here is we have three different pieces. So first piece is here, that's a function 4. Second piece is here, and that's a function which is 3 minus x squared, which is a parabola. So this is the piece. It's a part of parabola, like y is minus x squared plus 3, right? Parabola that opens down and then moved up 3 units. And finally, the last piece, the third one, is just a line. It's not the whole line, it's just a portion of line. So you can see it here. This line is on the picture. So this whole picture is produced from 3 pieces. And that's the reason why they call this as a piecewisely defined function. So you graph basically 3 different pieces and then put them together on the same picture. And you say, that's pretty odd. Why would they need it? Well, there are some exercises in this chapter related to this piecewise functions. So if you decide to do some homework with this type of problems, well, then I guess you'll find them in the textbook. So I thought I better tell you something about them. So let me go to the actually back of the section and try to do some problems here for you. So the first page is talking about those functions and not functions. So it wants to make you decide, is this relation is a function or not really? So I'm looking at the exercise number 1, and I say to myself, each relation, each point is related to only one element in the range. So it is a function. So we don't have 2 arrows coming out from the same exact element of domain, even though they may end up at the same spot, but that's fine. So they all went to visit, let's say, 3 or 7. So we do have a function. The only one that is not a function is in exercise 4, isn't it? Because 6 is no good. 6 is related to -6 and to -7 at the same time. So we don't have a function. So one needs not to panic. If it's function, great. If it's not a function, it's fine. It's okay. So some of them are not functions. So anyways, let me see the next page. So it looks like they have lots of various exercises of the same kind in here. So we can try to look at the next page with graphs. And this vertical line test story deals with the graphs of not functions, like the one here, for example. It's not a function, so say not a function. Why not? Do you remember? Vertical line test fails, right? Because there is a vertical line I can find. Actually, there are plenty of vertical lines, even our y-axis, which is vertical line, that intersect this wiggle in so many places. So more than one intersection. This is it, not a function. And others, like 42, for example, is a function because you have only one intersection for rightward function. Any vertical line. So vertical line test is very popular to determine if you have a function or not. So these are pretty nice and straightforward little exercises. As Alex, looks like you're skipping lots of problems in here. Well, what I want to do is concentrate on what we really need to review. So we prepared for the business calculus. They throw on us some other exercises, and I don't think we're going to be using them in the business calculus. Since it's just a review, I'm concentrating on what we really need. So we need to know what is function, what is not a function. And today I also want to graph one piecewise defined function for you. And I'm gonna just graph one today. I don't want to overwhelm you with all that. So I'll just graph one, and then next time on Wednesday, I'll graph you another. So let me try exercise like number 57, for example, from this group of exercises that say graph. So in exercise number 57, here I have a function f of x, which is given as a pair of equations. So the first one says y is equal to 6, and the second says y is equal to x squared. So I can graph both of those separately. So the first one that says y is equal to 6 will be the graph that passes through point 6 on the y-axis. You say, wait a second, why is that? Well, if you have y is equal to 6, it doesn't mean that you have only 1.6 on y-axis. It actually means that we have a line, and to get a graph of line, you can select any value for x. For example, you can select 0. That's my favorite choice. Well, guess what y is going to be? It's 6. That's what my equation says. You say, what if I select 1 instead of x? Well, y is going to be 6, because y wants to be 6. It doesn't care what x is. If x is 5, doesn't matter. Y is still 6. So if you plot these points on the plane of coordinates, such as a 0, 6, right? That's the first point. The next point will be someplace here with coordinates 1 for x, and then 6. The next point will be someplace probably up here with x equal to 5, and then 6. So all of these points are going to be on the same horizontal line. So that's why it's y is equal to 6. It means that x is any number whatsoever. So we don't really care for x. Y is 6, period. But x is any number. So it's a horizontal line. And for the second graph, well, we have our new favorite. It's a parabola, right? That U-shaped curve, that's the one we already saw today. Well, now I should be careful, because there's little extra information associated here. So it says that if x is equal to -2, then we select 6. So only at one particular point, at the point x equal to -2. So someplace here to the left, when x is -2, then y is 6. So this is the only point that I care about from this entire graph. So let me get the new set of coordinates, x and y. So I can actually put this point, -2 and +6, someplace up here. So here's one part of the graph. So what's the other part of the graph? Well, that's going to be parabola, but without -2. So when x is equal to -2, notice that -2 squared is 4, isn't it? -2 times -2. So when I put -2 instead of x, I square it and I get 4. So this point is not on parabola. I have to pinch it out because it says x is not equal to -2. You see, x is different with -2. So whenever you have x equal to -2, that's it. You're just using 4. So the question is, how do I get my graph? Well, please notice that point -2, so this is 6. And 4 that you took out from your parabola is a little bit lower. So this point that we pinched out is a little bit lower than the one that we have. So my parabola with a hole, and it is right here. So, well, I produced the graph. And this graph is a graph of a function. I say, well, Alex, no wonder it's a function because that's a f of x. Whenever we have a function, there is a special way to name it. Function of x, f of x. So we've got ourselves a point, and that's great. Well, and this is it. I just produced the graph. So someone pinched the point out and put it above the graph. You say, why would they do this? Well, that's the case with all of the piecewise defined functions. So all of these graphs will have some kind of holes in them or 2 pieces put together. So I just show you that there are various functions. In this class, I'm not going to really concentrate much on those piecewise functions because I know they kind of lengthy and annoying to graph, but one should be familiar with this. So next time, I think I will do another exercise on this section related to this story. And I guess that's pretty much all I think we should be talking about in here. So at the end of this story, I can put the link to the textbook again here in the chat. So in the case if you missed it somehow, here's the textbook. So you can check the chat and see that I have this link for you. You can just click on it and the textbook should open. So this week, I will not be able to come to the college, but starting next week, we'll resume as usual in face-to-face format. So Wednesday and Friday, these 2 days, will be on Zoom. So I will record lectures for you and later send it to everyone. So this week, you don't have to come on campus. If you want, you can come, that's up to you, but you don't have to. And next week, starting Wednesday, because Monday is a holiday. Monday, there's no class, no school at all. So Wednesday, I'll be back on campus. So on Wednesday, we'll continue in the classroom, but not this week. So this week, try to make sure that you get on Zoom. Looks like you're already on Zoom, but if somebody still has issue logging in, well, maybe you can help someone, that'd be nice, or just direct them to the campus library because they will help. And if you try to log into class when the class is not in session, log into Zoom. Well, the Zoom will say, just wait for the host, for me, to actually start the meeting. So if I didn't start the meeting, then you won't be able to log in because there is nowhere to log in, basically. But it will give you like this a white box on the screen that says just wait for the host to log in, and that way at 10 o'clock in the morning on Wednesday, you should be able to log in. But if you want to check if everything works, you can just click on the, and if it says wait for a host, means you're fine, that you will be able to log in when I get back on Zoom, which is going to be on Wednesday. So you'll have to wait for 2 days. You can just log in at 10 o'clock on Wednesday and we'll continue with all that. So I gave you the book. Make sure you have it. Means that you downloaded it. And I guess I'm going to stop with all that right now. So I stop the